The cosmos is always sending us messages. Whispers carried on the solar wind, echoes of events that happened millions or even billions of years ago. These messages arrive in many forms, some subtle, some dramatic, all waiting to be deciphered. Sometimes these messages arrive in the form of light, electromagnetic radiation spanning the spectrum, each wavelength carrying information about distant stars and galaxies. Sometimes the universe sends us messages as rocks, icy fragments, and metallic debris, hurtling through the vast emptiness of space, remnants of planetary formation, or the aftermath of cosmic collisions. On October 19, 2017, a message of a different kind arrived. Astronomers at the Pan-STARRS telescope in Hawaii, a state-of-the-art observatory perched atop a dormant volcano, scanning the night sky for near-Earth objects, were about to witness something truly remarkable. They spotted something extraordinary, a celestial object unlike anything they had ever seen before. It appeared as a faint point of light, a tiny spark moving against the backdrop of distant stars. But its trajectory told a story of interstellar travel. Their job, day in and day out, is to watch for asteroids and comets, potentially hazardous space rocks that could pose a threat to our planet. But this object was different, exhibiting characteristics that defied easy categorization. It wasn't just another asteroid or comet, it was something far more intriguing. Its trajectory was not the elliptical orbit typical of objects bound to our sun. Instead, it was on a hyperbolic path, a curve indicating that it was just passing through. It was moving too fast, far too fast, to be bound by the sun's gravity, suggesting it had originated far beyond our solar system. This meant it was a visitor, an emissary from another star system, a cosmic traveler that had journeyed across interstellar space to reach us. We named it Oumuamua, a name that reflects its unique origin and purpose. In Hawaiian, Oumuamua means a messenger from afar arriving first, a fitting tribute to its status as the first known interstellar object to grace our solar system. It was the first interstellar object ever detected by humanity, a milestone in our understanding of the cosmos and our place within it. The discovery electrified astronomers worldwide, sparking a flurry of observations and theoretical investigations. For centuries we'd theorized that such objects must exist, wandering through the galaxy, ejected from their parent star systems by gravitational interactions. But now we had proof, tangible evidence that these interstellar wanderers were not just a theoretical possibility but a real phenomenon. Our time with Oumuamua was brief, a fleeting encounter with a visitor from another star. It was already speeding away from the sun, heading back into the vast expanse of interstellar space when we found it. Telescopes around the globe scrambled to collect as much data as possible, racing against time to learn everything they could about this enigmatic object. Before it vanished, disappearing into the darkness, swallowed by the immense distances of space. Every photon of light it emitted was precious, a valuable piece of the puzzle, a clue to its origin, its composition, and its true nature. What was it made of? Was it rock, metal, ice, or some combination thereof? Where did it come from? Which distant star system had been its home? The universe had sent us a cosmic postcard, a tantalizing glimpse into the vast unknown, and we were racing against time to read it, to decipher its secrets before it faded away forever. The more we observed, the stranger it seemed, defying our expectations and challenging our understanding of the universe. Its path, its speed, its very behavior didn't fit neatly into any known category of celestial object. It was an anomaly, a puzzle wrapped in an enigma. Oumuamua was a mystery, a cosmic riddle that captivated the world, and it was slipping away fast, disappearing into the inky blackness of space, perhaps never to be seen again. The chase was on, a desperate attempt to unlock the secrets of Oumuamua before it vanished from our sight, leaving us to ponder its origins and its meaning. When astronomers discover a new object in the vast expanse of space, whether it's a comet, an asteroid, or something entirely unknown, they start by gathering as much fundamental information as possible. It's like piecing together a cosmic puzzle, one observation at a time. What does it look like? What is its shape, its color, its surface texture? These are the initial questions that guide their investigation. What is it doing? How is it moving through space? Is it spinning, wobbling, or following a predictable orbit? Understanding its motion is crucial. But with Oumuamua, the answers to these seemingly simple questions were baffling, challenging everything astronomers thought they knew about space objects. Its brightness changed dramatically by a factor of 10 as it tumbled erratically through space, suggesting an extremely elongated, almost cigar-like shape, perhaps 10 times longer than it was wide. This was unlike anything seen before. No asteroid or comet observed in our solar system, or any other system for that matter, has ever exhibited such an extreme shape. Gravity and the constant battering of collisions usually round things out over cosmic timescales, molding objects into more spherical forms. So how did this object manage to maintain such a bizarre, elongated form, defying the natural shaping forces of the universe? Was it a fragment, a shard from a shattered planet ripped apart in some ancient cosmic collision? Or could it be something else entirely, something never before encountered? Then came the next surprise, an additional layer of complexity to this already perplexing puzzle. Its composition, or rather its apparent lack of typical cometary composition. Objects originating from the outer reaches of a solar system like comets typically heat up as they approach a star, releasing volatile gases and dust, creating the characteristic cometary tail. Yet, Oumuamua passed remarkably close to the Sun during its journey through our solar system, but it exhibited no tail, no detectable gas emissions, and no signs of dust production, nothing. It appeared to be completely inert, like a dry, lifeless rock, devoid of any volatile compounds. If it was primarily composed of ice, as many comets are, it should have undergone significant outgassing as it neared the Sun, but if it was primarily rocky, it shouldn't have been ejected from its home system with such ease, given the energy required. It seemed to possess the orbital characteristics of a comet, yet it presented the physical appearance and composition of an asteroid. It simply didn't fit neatly into any of our established categories or classifications of space objects. Oumuamua was, and remains, a true cosmic oddball, a unique and enigmatic object unlike anything astronomers had ever encountered before, defying many of the fundamental assumptions and established theories about the formation and composition of celestial bodies. With each new observation and analysis, the mystery surrounding Oumuamua only deepened, becoming more complex and intriguing. So what exactly was this interstellar visitor? What secrets did it hold about the universe beyond our solar system? The universe, in its vastness and complexity, operates under a set of fundamental principles. These principles, which we call the laws of physics, govern everything from the smallest subatomic particle to the largest galaxy. And among these laws, one reigns supreme in shaping the cosmos: gravity. It's the invisible force that binds celestial bodies together, dictating their movements and interactions. So, when Oumuamua, a mysterious interstellar object, swung around the Sun, scientists naturally expected its trajectory to conform to these well-established gravitational laws. Based on its initial velocity and the Sun's gravitational pull, its path should have been predictable, allowing astronomers to chart its course with precision. But to the surprise of everyone involved, it wasn't. The observations revealed something unexpected, something that defied conventional understanding. Astronomers, meticulously analyzing the data, noticed it was accelerating, gaining speed as it moved away from the Sun. This acceleration meant it was moving slightly faster than gravity alone could explain, hinting at an additional force at play. Some unknown mechanism was giving it a push, altering its trajectory in a way that defied expectations. Normally, comets, as they approach the Sun, accelerate due to jets of gas erupting from their surface, a phenomenon known as outgassing. But Oumuamua presented a puzzle because it had no visible outgassing, no telltale signs of gas or dust being ejected from its surface, no tail, the hallmark of a comet nearing the Sun, no coma, the hazy atmosphere that typically surrounds a comet's nucleus, no jets, no visible expulsion of material that could explain its acceleration. And yet, despite the absence of these expected characteristics, it was undeniably speeding up. The question arose, could it be outgassing something invisible, something undetectable by our instruments? Perhaps it was releasing a gas like hydrogen or nitrogen, which are notoriously difficult to detect in space. Faced with this enigma, some scientists proposed exotic ideas, pushing the boundaries of conventional astrophysics. One suggestion was that maybe it was a solid hydrogen iceberg, a previously unknown type of space object. Another hypothesis posited that it could be a nitrogen fragment from a distant Pluto-like world, a piece of a frozen landscape ejected into interstellar space. Each theory, while intriguing, tried to explain the acceleration without relying on readily visible evidence, attempting to reconcile the observed behavior with known physical processes. But despite their ingenuity, none fit perfectly, leaving crucial aspects of Oumuamua's behavior unexplained. We were left with a paradox, a contradiction between what we observed and what we expected based on our current understanding of astrophysics. It was an object that acted like a comet, exhibiting non-gravitational acceleration, but looked like an asteroid, lacking the characteristic features of cometary activity. The mystery of this unseen hand, this unexplained force acting upon Oumuamua, only grew more profound with each passing observation. Was it a new kind of natural object, a previously unknown class of celestial body exhibiting unique properties? Or was it something else entirely, something that challenged our fundamental assumptions about the universe and the objects within it? Driven by this profound mystery, the search for answers intensified, with astronomers around the world dedicating their time and resources to unraveling the secrets of Oumuamua. But despite their best efforts, Oumuamua refused to be explained away, remaining an enigma that continues to captivate and challenge the scientific community. When nature's rules don't fit, science demands bold thinking. Enter Avi Loeb, Harvard astronomer. He looked at the evidence, the shape, the lack of a tail, the unexplained acceleration, and asked, what if Oumuamua wasn't natural at all? Loeb proposed it could be alien technology, a solar sail pushed by sunlight. A thin, wide object would match the observed shape and brightness changes. No ice means no tail, and sunlight could explain the acceleration. It was a radical idea, but it fit the facts. The suggestion sparked fierce debate. Was this our first brush with alien tech? Loeb wasn't claiming it was a spaceship, just that we shouldn't dismiss the possibility. The universe had handed us an anomaly, and he argued we owed it to ourselves to consider every explanation. Science thrives on skepticism. Most astronomers urged caution. Extraordinary claims need extraordinary evidence. The search for natural explanations continued. Some proposed Oumuamua was a hydrogen iceberg, lightweight, sublimating invisibly. Others suggested a nitrogen iceberg, chipped from a Pluto-like exoplanet. Both ideas could explain the acceleration without a visible tail. Occam's razor guided the debate. The simplest explanation is usually best. For now, most scientists lean toward a strange natural object, not alien tech. But the debate remains open and healthy. Studying Oumuamua was like photographing a speeding bullet in the dark. It was moving at 58,000 miles per hour and already leaving the solar system when discovered. We had only weeks to observe it before it faded from view. We never saw more than a point of light. Its shape and composition had to be inferred. No spacecraft could catch it. It was gone too fast. Interstellar visitors are rare and hard to spot. For everyone we find, countless others slip by unnoticed. The discovery of 2I/Borisov, a more typical interstellar comet, showed we're getting better at finding these objects. But Oumuamua's strangeness remains unmatched. To solve mysteries like Oumuamua, we need to find more interstellar visitors. The Vera C. Rubin Observatory in Chile is our next leap forward. With its massive mirror and record-breaking camera, it will scan the southern sky every few nights. The observatory will generate a flood of data, making it possible to spot faint, fast-moving objects. Soon we may find dozens or even hundreds of interstellar objects each year. We'll be able to track them earlier, observe them longer, and study them in detail. If we find more objects like Oumuamua, natural explanations become more likely. If not, its uniqueness will deepen the mystery. The Rubin Observatory will transform the search for interstellar visitors into a true science. Observing from afar is one thing, but to truly understand interstellar visitors, we need to reach them. The challenge. These objects move incredibly fast. Project Lyra proposes a high-speed probe, ready to launch when the next visitor is spotted. Advanced propulsion like solar sails or gravity assists could make an intercept possible. A probe could image the object, analyze its composition, and even sample its surface. This would finally answer whether it's natural or artificial. Planning such missions pushes our technology and imagination. These visitors are practice targets for future interstellar exploration. They invite us to take our first real steps beyond the solar system. Oumuamua's story is more than a puzzle, it's a turning point. It reminds us that the universe is dynamic, full of surprises, and sometimes sends us clues from afar. Whether a nitrogen iceberg or alien artifact, Oumuamua changed our perspective. It proved the gulf between stars is crossable, and that pieces of other worlds drift through our own. This realization fills the cosmos with new possibilities. It suggests planets, and maybe life, could be exchanged between star systems. Oumuamua sparked new theories, new telescopes, and new missions. It forced us to confront the limits of our knowledge and to stay open-minded. We may never know exactly what it was, but it awakened us to the reality of interstellar visitors. It reminded us to keep looking up. The universe has more stories to tell. The next great discovery may be just around the corner.